Good evening, everyone, and welcome to the 2022 SLL Young Lighter Final. My name's Helen Looms. I'm the SLL President-elect, and I am delighted to be here hosting today's final. The Young Lighter competition provides a unique platform for those in the early years of their lighting careers. Their presentations allow the young lighters to illustrate their knowledge and research on a lighting subject, hone their presentation skills, and raise their profile within the industry. And I'm very pleased to say that the competition is going from strength to strength, and we're now celebrating its 28th year. The process starts for the competition with a PowerPoint presentation of their topic or paper, and then, if selected for the second round, they produce a short video blog enabling them to demonstrate their ideas and concepts further. The judging process then determines the finalists, who get 15 minutes to present their papers this evening. The winner of the Young Lighter 2022 will be announced once all the finalists have presented and the judges have completed their review. For their efforts, each finalist receives a cash prize of £250 and a year's membership to the SLL. The overall winner gets an additional £1,000 cash prize and will be named SLL Young Lighter 2022. Once again, the standard of applications was very high, making it difficult for the judges. And I'm pleased to say that we have 4 excellent finalists for you to listen to tonight. First up will be Anna Forrester, who's improving the circadian rhythms in children through the means of a lighting device. She will be followed by Scott Kluger, who's talking about Daylight Harvester, a tool to enhance lighting operational performance. Then we have Hiba Mazhar, Do We Own Night? Reimagining the traditional city lighting with a new light recipe to confiscate light pollution. And then finally, Cliffe, Adapting to the Digital Future, Surveying. So our first paper this evening is from Anna Forrester, Improving the Circadian Rhythms in Children Through the Means of a Lighting Device. Anna has spent the last 4 years working in Manchester as a lighting designer for Arup, having graduated from Brunel University in 2018. She's recently moved to Houston, Texas with Arup to continue developing her career. And she is presenting her concept product of Sleep Steady, a child's nightlight that aims to reduce the impact screen use has on young children. She's always been interested in how light can captivate, influence, and inspire us, and concepts she aims to bring to the forefront of her designs. So, Anna, I'd like to hand over to you.
Thank you very much. Let me just share my screen. Can everybody hear me and can everybody see me? Cool.
Yes, that's fine. Thank you.
Yeah, fab. Awesome. So thank you very much for that introduction. So I'm actually currently calling in from Austin, and it's a very balmy 20 degrees Celsius here this morning with a nice blue sky just to really rub it in everyone's face in the UK. So I'm going to be talking about Sleep Steady, which is a product that I have designed and created to reduce the impact that screen light can have on the circadian rhythms of young children. So I've sort of broken this down into 3 key sections to sort of keep us on track and so everyone can kind of follow the design process that I went through. So before we get onto the final sort of design, I'm going to talk you through about the research that went into this project, and we'll focus on sort of 3 main topics, just to give everyone a bit of an overview. So those are, what are our circadian rhythms, how does light impact them, and what do screens have to do with it, sort of especially in children. So I know that lots of us on this today are lighting designers and sort of have an understanding of our circadian rhythms, but for anyone who is unsure, this is kind of just a brief synopsis. So our circadian rhythms are 24-hour fluctuations in behavior and hormone release, and it's displayed in everything from the smallest cell all the way through to humans. They modulate timing and response in our sort of sleep and when we feel hungry and when we feel tired, and they'll tell us when to sort of eat and wake up. So the regular rotation of Earth for the last 3 million years has created a cycle that's synchronized to 12 hours of light and 12 hours of dark, sort of give or take. A really fun fact that I like that shows how important these rhythms are is fibroblasts in our body. So fibroblasts are a cell that fill the void when you have a physical wound, if you burn yourself. And it was discovered that these cells are impacted by the host circadian rhythm. And if I burn myself on this arm during the night, and if I burn myself exactly the same on this arm during the day, the burn at night will take 11 days longer to heal because the cells are in their sleep stage of their circadian cycle. It sort of shows how important they are, and also to, if you're going to hurt yourself, make sure you do it during the day. And in this modern age, we're focusing on understanding how this cycle works in, office spaces and planes if you're doing red-eye flights, and hospitals as well, to kind of make people more comfortable, give people more autonomy, and help people heal faster ultimately. The hormone that us as lighting designers generally focus on that is impacted by circadian rhythms is your melatonin production, which is a hormone that's key in sleep. It creates drowsiness, which makes us feel tired. It's super synchronized to our circadian rhythms and is produced from the pineal gland. The greater the amount of melatonin we have, the sleepier that we sort of feel. So circadian rhythms in humans are regulated by this very small nucleus that's present in the center of our brain, called the SCN, so you can see it up on screen. It's the sort of control center that keeps our body on its cycle. What's important about this and why light has such an impact on it is it has a direct connection to the retina and to the ocular nerve. So there's specialized cells in our retina that relay sort of light information to the SCN, which keeps it synchronized. And because of this direct connection, it's why light has such an impact. But as we might know, different wavelengths and different colors and different intensity of lights impacts the rhythm differently. Light color specifically has a direct correlation to the production of melatonin in our brain. So shorter wavelengths of blue and violet light suppress melatonin production so much more than red light does, due to the length of the wavelength of the light. As well as being heavily influenced by color, there's also a relationship between melatonin production and illuminance. So light above 100 lux will suppress your melatonin within about 5 minutes. Light below 100 lux doesn't have quite as much of an impact. So from sort of an initial stimulus being shown, it's as quick as 10 minutes for it to start suppressing. But what does this ultimately mean for us? So in today's very technology heavy world, screens are a massive part of our everyday life. They emit a high level of this very short wavelength blue light that obviously, as I've spoken about, does suppress melatonin, does stop you from feeling sleepy. And this lack of sleep does have a negative impact on our brain development, and especially in children. They're developing so fast and so quickly that even kind of losing half an hour to an hour's worth of sleep can have a huge impact on their development. The problem is the engaging nature of devices has much stronger links to children and adolescents in this kind of negative sleep habit. And there's actually a new term called asynchronization, which refers to daytime sleepiness and insomnia in children, which is very much on the rise. So collating all of this research, it kind of gave me a clear focus area of this is something that I feel I could have an impact on. I looked at sort of existing products, and it was sort of clear that there is a very key area for opportunity for a product that's sort of low cost, circadian based for children, that has almost an interactive element or something that gives them a bit of autonomy over it. There's all sorts of child's night lights on the market. A very small handful have kind of a circadian element, and a lot of those are quite expensive. And a lot of these are really fun. I really like the design of them. They're no longer, night lights are no longer kind of just like a dim bulb on the wall. You can have projections and music and characters and everything from My Little Pony to Marvel, and each of them have a respective pro and con to them, but there is sort of a missing area, which is where I'm sort of focusing on. So I was able to round out this research into a concept brief that tied in both the sort of market niche and the opportunities. So I wanted to create a light that would help reset the circadian rhythms in young children as that main output. But I still wanted there to be a level of personalization, for people to take control and ownership of it. So this leads us into the design and development stage. It's about halfway through. So I spent a lot of time iterating and sketching different concepts. I discussed these with stakeholders and parents and kids to help narrow down which area I should focus on. So because this is only a 15-minute presentation, I am skimming over a lot of the very sort of product design heavy stuff. But please reach out to me if you want to talk about it further. I have all sorts of information and pictures and sketches and notebooks that I can show you and talk you through. So these are varying sort of early design iterations that we evaluated for sort of viability, and it was decided that we wanted to go with something that was desk-based, and it was kind of designed around this glowing, sort of slightly orb kind of interactive disc shape with a desired function that would be a set cycle to sort of mimic the light that you would receive if you were outside all day during the day. And we looked at doing that through both color and brightness. And those we decided to put in some interactive features as well, which we sort of focused on storytelling, bedtime stories, and you're sat there and you sort of create a bedtime story with your children. So we wanted to bring that kind of element into the design. So these are some final GAs and models. We just, this is all about sizing and making sure it's big enough for kids to be able to hold it without it being, huge, but still small enough that it would look the right size on a bedside table. The shape is kind of this divot shape because we wanted to be able to put a glass of water on top of it if needed, because it will help reflect the story elements as well, sort of up into the room. What you will notice through the rest of these slides is there's a couple of different models. Because of the miniaturization of electronics, and this was done in quite a short space of time, we have an aesthetic model and a functional model and an electronic prototype. So they do look slightly different, but it's sort of showing what it would look like, how it works, and sort of the coding behind it. So that's why there's some differences. So a range of different models were made, again, to avoid getting too bogged down in the product side of it. These are just kind of a couple of images of all the different elements that were kind of built and put together. PCBs were created, and different materials were used. So Urial, which is a very high density foam, was used to make the base plate, and then a HIPS thermo-molded top was then created to sort of create that divot shape, which was sprayed with a mix of white and clear paint to sort of give the 30% transmission that I was looking for. Again, as I've talked about, I have a lot of information about how this was built, so please do reach out. The video that you can see is of a NeoPixel ring, which is a little LED ring that I use to create all the different colours and different colours basically within the product. So this NeoPixel ring was Arduino coded, and it had the ability to create every colour within the RGBW spectrum, which gave me kind of a huge amount of flexibility with the colour and the brightness that I could then use. So to keep the design as close to the natural circadian input, I sort of assessed each time period, translated the Kelvin colour to an RGBW system, and then I coded that into the LEDs. So the Kelvin values were split out into sort of 5 distinct temperatures. When translated over to RGB, I then dropped the brightness to avoid short-circuiting the NeoPixel ring and making it too bright to be a nightlight. So there's a couple of screenshots of the coding here. Again, I can talk about it more in depth, but we don't have enough time for that. As with all designs, whether that's a physical product, whether it's a lighting installation, whether it's like a daylighting design, they all go through different journeys before you sort of settle on a final output or a product. So this is just a sort of quick design tree that showed different avenues that were explored and why they were or weren't chosen. Each route was kind of coded and analysed before being, decided if it was valid for the design process or not. So the final design allows for daylight mimicking lighting through the use of this NeoPixel ring and the ability to code the RGBW to make it the correct colour settings. So after all of this, we had a final physical product, which I've named Sleep Steady. Lots of different names were toyed with, lots of different names were run past stakeholders and parents, Sono, Valo, Lunama, but Sleep Steady was the one that resonated with most people, and it's the one that we have ended up with for this design. So overall, the key aim for Sleep Study was to create a kids' nightlight that would reset the circadian rhythms in children that have been impacted from the blue light through screens, whether that's through home or school use. The final design does achieve this through dynamic timed lighting that works in parallel with natural daylight, and the research and analysis throughout the project allows the development and design to create something that excited people. Kids have been really keen to use it and play with it and change the discs and pick, if they want dinosaurs or princesses or ponies. And I think it's clear that circadian rhythms and the impact technology can have on them is becoming an ever more prominent topic in our ever connected world. I know that I'm working on projects at the moment where circadian rhythms are very much the forefront of the conversation. As our reliance on technology increases, human health and well-being is becoming the leading area of design, and it's become a big interest of mine, and I'm sort of looking to spend more time developing this sector of research and design as my career moves forward. So this is a slide that kind of details a bit more in depth some of the different areas of the design, from the light transmission percentage of the plastic to the interchangeable sort of story discs that can be used, to the RTC. So there's a real-time clock as part of the PCB encoding. So whenever you plug it in or turn it off, it knows where it is in the cycle. So you don't have to reset it every time. You don't have to, plug it in and then put in the time necessarily. You plug it in and it knows where it will be in the 24-hour cycle. I was able to sort of do a rough calculation of manufacturing and electronics and come in with a price point of sort of under $20, $25 when made, manufactured professionally. So it kept me in that low price criteria. So the finished prototype is very much a starting point for a sort of very interesting design path. This is a video that's been sped up to see sort of the light output as it goes from like the bright daylight colours through into the evening to the red and light colours and sort of back again. Obviously, in reality, this would happen over 24 hours, but we only have 15 minutes. So this has been sped up to be done in about 15 seconds, but it should sort of give you an idea of what it will look like. The lighting industry is experiencing rapid transformation as we expand our awareness of the non-visual impacts of light on humans, and it starts, with the new generations, the children, the up-and-coming people that are sort of coming into this world. I'm aware that more and more of these lights are popping up onto the market every day. I, have one that does the sort of sunrise wake up instead of an alarm, but there are a few that I found that are both at that affordable price point and are aimed at children in that younger age range. And this is a niche that I sort of hope to have filled. Okay. So these prototypes were shown to a range of parents and children, and we had lots of positive feedback and ideas for progression. So there's sort of an interesting journey ahead of me to sort of see where this will take me. And I'm excited to kind of develop this further. So I thank you very much for your time this evening, or this lunchtime if you're dining in from the States. I have all my references available, and I'm always keen to discuss this, so please do reach out to me if it's something you want to ask about further. And yeah, I hope you enjoy. I appreciate you listening to my journey with the Sleep Study product, and please do enjoy the other 3 finalists. They have incredibly interesting projects, which they are going to discuss with you, and you're really in for a good and informative evening. So thank you very much.
Well, thank you, Anna. This was really interesting, a beautifully put together presentation as well. So thank you for all of your efforts. Right, now we would like to move on to our second presenter, whose paper is entitled Daylight Harvester, a tool to enhance lighting operational performance. Now, Scott's passion for lighting began during his final year at architectural school, where he explored how light could be used as a form of therapy for people affected by dementia. Since then, he's worked on a broad range of lighting projects across the UK and abroad, and is continuously seeking to improve the balance between human-centric and planet-conscious lighting design. Recently, Scott has shifted his focus towards daylight and is helping to improve the integration of daylight within lighting design practice, driving a more sustainable and holistic approach towards light within a net zero future. So Scott, over to you. Thank you.
Thank you, Helen. Can everyone see my screen and hear me?
Yep, that's fine.
Awesome. So yeah, today I'm briefly going to talk to you about my idea of the Daylight Harvester tool, which can help optimize lighting energy performance. By now, we've all become very familiar with recent events regarding the rising cost of energy and increased temperatures due to climate change, which are making societies all around the world acutely aware of their carbon emissions and the impact this is having on both the environment and the economy. In response to these events, the UK government and building industry are moving towards a net zero carbon future. However, to achieve these ambitious targets, it is expected that regulatory and performance-based metrics relating to energy and carbon will become increasingly more stringent and mandatory. And for the lighting profession to journey towards net zero, we must look towards a more holistic approach towards how we light our buildings. My proposal for the Daylight Harvester hopes to shine a light on how daylight simulations could be used as a tool to help inform the lighting design process and provide an opportunity to take a step towards net zero lighting design. Firstly, however, we must start our journey by seeing how lighting energy is currently measured in the UK. And for this, Part L is recognised as one of the most important compliance documents to achieve. Within the lighting category of Part L, there are two methods available. The first option is based on luminaire efficacy, requiring an average luminaire efficacy of 95 luminaire lumens per circuit watt. Here I've considered it sort of a static approach towards energy, as it provides a single value to assist in the specification of luminaires. Although efficacy is an important aspect to consider when specifying luminaires, it does seem arbitrary that this can sort of extrapolate towards a benchmark for lighting energy performance, particularly with no energy parameters for designers to work with. So it effectively gives kind of a free pass to use as much light as possible. In contrast, the Lighting Energy Numeric Indicator, or LENI for short, is a much more comprehensive method towards measuring lighting energy performance and does consider the impacts of space, illuminance, and daylight. And these inputs vary from building to building, and it could be categorized as a sort of dynamic approach towards measuring energy. And compared to the previous method, on the face of it, it seems more relevant within the context of net zero lighting design. However, LENI is hindered somewhat by its complexity and in particular its measurement of daylight. In contrast to other design factors, which are relatively straightforward to calculate, daylight requires a much more complex calculation process. So it kind of requires a designer to reference sort of up to 50 pages of equations, reference tables, and geometric parameters to determine the daylight contribution of a space. And so this sort of manual-based approach towards calculating daylight can, I guess, be considered quite repetitive, time-consuming, and somewhat daunting process to undertake. So on the face of it, LENI's sort of manual-based approach to daylight doesn't really reflect the modern workflows of engineers today, but by replacing this approach with climate-based simulation tools and algorithms which sort of reflect the processes of today, the aim is to help sort of improve the LENI methodology and make a much more effective tool for lighting designers. So the tool was therefore developed with two design parameters in mind. Firstly, it needed to adopt simulation tools which were sort of popular and industry standard within the lighting and building performance community. And the other major component that was needed was that it had to be able to integrate within different aspects of the design process and be able to enhance these workflows at different stages of the design. So let's first look at the application of the Daylight Harvester tool during the conceptual design stage and how it could help to enhance the lighting design process towards net zero. So even before a lighting design has begun, the tool can be used to provide sort of initial energy parameters for a lighting scheme, which are Part L compliant with daylight dimming controls. So let's take this sort of hypothetical office building in the city as our example and test sort of a typical floor plate. So to begin with, like any lighting design, you know, we've got our illuminance thresholds determined by space types, which characterize, you know, with your office areas, breakout spaces, and so on. And step two, the maximum energy requirements of each space type are then derived from part L. So for example, a meeting space of 500 lux must not exceed 12.23 kilowatt hours per meter squared per year, and so forth. Afterwards, a climate-based daylight analysis is simulated using the useful daylight illuminance metric to measure the percentage of time during the year daylight achieves an acceptable level of illumination. In step 4, daylight performance is then post-processed to estimate the percentage reduction from the part L baseline with daylight controls. And in step 5, this information is then used to estimate the energy of each space with daylight control. So if we compare the results in step 5 to step 2, we can see a general reduction in energy with daylight dimming controls across all the spaces. However, in the lighting design process, a specification process as well, it's recognized that power is a much more useful unit compared to energy. So the tool can also convert the cumulative energy into average power across a year. So the values shown at the top provide the average power consumption required to achieve part L. But to help optimize the lighting design process, the tool can also estimate the maximum power allowance of a space with daylight control. So the idea being that the installed power of a space can be increased so long as daylight controls are operating to remain compliant with part L. So in this example, the average power consumption across this office floor has increased by almost 1200 watts, with different areas of the floor increasing dependent on its level of daylight performance. So the intention is to provide designers increased flexibility when designing for visual comfort, whether that be through layers of light or providing decorative fittings which may have less efficacy, or additional architectural lighting. But by using daylight as a tool to offset energy, it can provide a designer with greater flexibility towards designing for visual comfort. And at the concept phase, it was really important to measure daylight spatially within the tool. And the main reason for this is that changes to spatial layouts, facades, and materials can play a really huge role on lighting energy performance, particularly with daylight controls. So for example, if we from the baseline condition from our previous example here, we can compare it against sort of proposed changes to the design, such as, say, the rearrangement of interior spaces in option 1, or reduced glazed openings in option 2, or changes to light and material palettes in option 3. So with the tool, these architectural changes can be quantified and compared to push for a more energy efficient design, which can maximize daylight and allow greater flexibility for the lighting. So I've shown previously how the tool can help to maximize power with appropriate daylight controls to provide flexibility with both luminaire specification and lighting design, but rather than just increasing power for spaces which are sort of already well daylit, these savings could be used to offset spaces which have limited access to daylight and require more artificial lighting to better improve visual comfort. So how can areas of a building with good access to daylight be used to offset non-daylit spaces which are more energy intensive? Rather than just applying simple room by room analysis of a building, how can we use tools such as this to be able to think of daylight, lighting, and energy more holistically? So it's hoped that by using sort of this tool during the conceptual phase, daylight can play a much more active role in helping to not only maximize visual comfort and energy performance within the lighting design process, and to think of the process of lighting energy performance more holistically. Next, we move on to the technical phase and how daylight simulations could be adopted to help inform lighting controls and provide a benchmark of performance for daylight dimming systems. So in contrast to the previous stage, which focused on the spatial characteristics of lighting energy performance, here the focus becomes on the predicted performance of the daylight dimming system itself. So using individual sensors to mimic how a daylight dimming system operates in real time. So each daylight sensor records the hourly daylight values across a year, which are then post-processed against the required illuminance threshold of the space to provide an hourly artificial illuminance schedule. So this information can then be used to produce a temporal map, as shown here, illustrating when artificial lighting is required, its illuminance requirements, and for how long. So a comparison between each sensor suggests that in this example, the north sensor at the top will require lighting at higher illuminance thresholds for longer durations to achieve the desired 300 lux target. In contrast, daylight sensors positioned to the south and east, which have good access to daylight, will only require higher illuminance thresholds for smaller durations and primarily focus only during the winter period. So this information can help design lighting which can respond to seasonal variations and present an opportunity to further reduce energy. For example, a daylight sensor which rarely requires full output to achieve 300 lux suggests that there is ample daylight within that space and a potential to design to a lower illuminance threshold to reduce energy. Or what if the task illuminance could vary according to the season, such as 300 lux during the winter months and 200 lux during the summer periods, rather than designing towards fixed illuminance thresholds to be achieved throughout the year, should the task illuminance vary according to daylight? This information can then be used to provide hourly power schedules with daylight dimming. So these temporal maps are linked closely to the previous slide with higher illuminance thresholds equaling higher power output. One benefit of identifying seasonal power loads from lighting systems is that it can provide a benchmark tool for designers to compare predicted performance with actual performance. As we move towards a more performance-driven future with regards to net zero, it will become increasingly more relevant that the systems we design for operate as intended. All too often, daylight dimming systems are sort of incorrectly designed, commissioned, and left as somewhat of an afterthought within the lighting design process. And often these systems don't really work as intended. But by giving designers a tool to provide a benchmark in energy performance, it's hoped that this information can help to improve the design and commissioning of daylight dimming systems and improve their expected performance when it comes to the in-use phase. Which brings us to the last aspect of this tool and how it can be adopted during the in-use phase as a means of improving existing lighting systems. For this case, we're using an example of the daylight harvester for a proposed refurbishment of an office in London. Here, the client was seeking to explore ways in which to save energy, and lighting was identified as a key contributor at almost 38% of the total energy consumption. Within the growing context of the circular economy and reducing embodied carbon, rather than simply replacing all the existing fluorescent lamps with LEDs, the tool was adopted as an alternative to reducing operational energy performance and reducing the body carbon of replacing the luminaires. So a daylight sensor for each bay within the office was used to measure the hourly illuminance values of daylight, which was then post-processed to provide an hourly illuminance schedule required for the artificial lighting to maintain 500 lux on the task. The impact of glare was also measured, as it was an important contributor towards increased artificial lighting levels when the blinds were closed. So in this table, a comparison between the existing and predicted performance of the daylight dimming system is compared. As there is no change to the fittings themselves, the power consumption per bay remains the same. However, energy consumption has dropped with the use of daylight dimming, with variations in reduction dependent on the daylight performance of each bay. Expressing daylight performance in terms of energy, carbon, and cost help to present to the client what impact a daylight controlled system could provide to the existing lighting scheme. These tables summarize that for daylit zones, almost 64% of the energy could be saved when this was extrapolated across the whole office, this amounted to approximately 17%. This process offered an alternative approach towards replacing all the luminaires within the office with LEDs. The information helped to quantify our sort of design decision to maintain the existing fittings within daylit zones and focus the replacement of luminaires within non-daylight zones instead. Here, the use of daylight simulation tools help to not only provide energy savings, but also help to reduce the embodied carbon with the refurbishment. So as lighting designers, we need to approach net zero holistically and think beyond just a circular economy and product-based approach towards sustainability by developing a tool that can improve the accessibility of daylight within energy performance calculations. It's intended that the daylight harvester can help spark a better integration of daylight and artificial lighting and help improve the lighting design process towards a net zero future. Thank you.
Well, thank you very much, Scott. Anything that can demystify Lenny has to be welcome. So well done. Our next presenter is Hiba Mazhar, presenting Do We Own Night? Reimagining Traditional City Lighting with New Light Recipe to Confiscate Light Pollution. Now, Hiba has been working as a lighting application specialist for Signify in Pakistan for the last 3 years. She graduated as an architect from the Department of Architecture and Planning in NED University of Engineering and Technology. During her undergraduate journey, she was entirely fascinated with natural and artificial lighting, which eventually led to her to become Pakistan's first female architectural lighting designer. She is currently involved in light and sustainability research movement for Signify and develops research-related lighting and its inaccurate application within ecosystems. She is also initiating to produce lighting application as a subject in architectural and engineering schools in Pakistan to promote right lighting practices and designs. So Hiba, please take it away.
Hello, everyone. I hope I'm visible and audible clearly. Please somebody confirm me that.
Can you put it into presentation mode, please?
Yeah, sure.
Thank
okay,
you.
so as I've already been introduced, and I'm glad for such an amazing introduction. Thanks, Helen. So today I'm here for maybe not to just present the research topic or presentation, but I'm here to highlight a very neglected topic, condition, and a question. Do we own night? I'm sure that by the end of this presentation, we're surely going to have an answer or at least a clearer mindset. So, my dear fellows, all participants, judges, and finalists, I would like to take you on a journey. A journey, a 2-minute outlook on Earth at night via satellite. You will be on space, and if you are ready, here it begins. So ever looked at Earth at night? Let's have a look at our globe via satellite. City lights of Africa, Europe, and Middle East. What do we see here? Light spots, highly illuminated from far distance. Nighttime view of Western Europe, England, Paris, Belgium, and Netherlands. Seems like heavy light explosion all over. Composite image of Europe at night via satellite. High illuminated spots again. Entire Berlin via satellite, you guys. We see highly illuminated lanes, highly illuminated spots. Puerto Rico, just after Hurricane Maria. You can see the graph below from dark to heavy light application. City lights shine brighter during the holidays in the United States when compared with the rest of the year. Yellow spots are very visible. North and South Korea, white inset box shows light of the fishing boats in Yellow Sea, high illuminated and light explosion again. In several cities in the Middle East, city lights brighten during the Muslim holy month of Ramadan. Yellow spots highlighted again. Germany, Belgium, and Netherlands via satellite. Heavy light applications. Nile River and surrounding region, all illuminated without any balance of dark and light. What's happening? And the entire Earth at night. Even from far a distance, we can see light explosions. What has gone wrong? What has been affected? Who has been neglected? Humans, animals, environment. And what was the cause? Light pollution. NASA Earth Observatory and satellite images revealed in past years that 83% of entire world and almost 99% of population in US and Europe live in areas that always have excesses of artificial lighting at night. Moreover, this rate has increased by 2% every year. So what is causing light pollution? Light pollution is caused by four major elements. Sky glow. Please look at the cursor to understand the image, please, which refers to the brightening of the night sky over inhabited areas. Glare, which refers to excessive brightness that causes visual discomfort. Light trespass, which refers to phenomenon of light appearing where it is not intended or needed. Clutter, which is the bright, confusing, and excessive group of light sources. So who has been affected and what has gone wrong? Increase in global warming. High-powered and glary lights has caused increase in global warming and created heated environment causing adverse effect. Human health. Humans don't tend to see dark nights anymore, which has disturbed their circadian rhythm to great extent. Energy consumption. High powerful light uses more energy and can have severe economic consequences, causing severe effects in all ways. Dark skies. Glow of unshielded light on Earth has hidden the stars and disturbed our urban spaces. Safety and security. Glare from bright unshielded lights actually decrease safety and can cause severe accidental problems in urban environment. So, who has been affected? Only humans? I believe that in all of this artificial ambience and artificial lighting, there is something that has highly neglected. Wildlife and ecosystem are the most to be damaged. Nocturnal animals, marine animals, insects, birds. We tend to forget them when we talk about light pollution. So as I've mentioned, what we have neglected, the topic of my research presentation is very evident. The main area will cover about adverse effect of light pollution and its effect on wildlife and ecosystem, and how we can solve it to get the right lighting application and light recipe to confiscate light pollution. So what are the effects on animals? How light at night affects wildlife? So light pollution can affect the fitness of certain focal species that can result into the population amount of those focal species. Light pollution also is affecting environment in many ways that can further affect physiology, behavior, and life history traits of certain animals and insects and species. For example, fireflies tend to get attracted to glary lights and they roam around the glary lights to the extent that they die. So if we consider the larger scale, in the larger scale perspective, almost all nocturnal animals are affected. Artificial lighting, when polluted, makes it difficult for birds to migrate and find their trajectories due to glary lighting. If we talk about bats and butterflies, they are also highly affected by delaying or preventing emergence from rows, resulting in reduced foraging time and missing the peak time of insect abundance, all due to light pollution. If we talk about marine animal and amphibians, they are also highly affected as they are at increased risk of mortality from fatigue, predation, dehydration, and collision with vehicles. Light pollution may also impact mother sea turtle as they attempt to nest and go for breeding. Now, on a smaller scale perspective, if you look at this hypothetical condition, where a band of street or highly illuminated partition crossing these lines hedges can block the species present here, right? How the
Oh dear, we seem to have lost Hiba. Hiba, if you are still there, can you maybe try and put on your mic, switch off your mic and put it back on again, see if you can rejoin us. No. Okay, what we will do then is I will move on to the next presenter, and maybe we can come back to Hiba when he has finished. So I'm very sorry for this. The next presenter is Kenny Cliffe, and he will be talking about adapting to the digital future around surveying. Kenny Cliffe is a lighting designer at Ridge & Partners, and as a graduate at Manchester School of Arts, he holds a bachelor's degree in the three-dimensional design. There is a physical aspect to lighting, a relationship between materials, textures, contrasts, and the fact that it is unnecessary for light to exist without darkness. All inspire his practice. And to date, he's been involved with a variety of world-class initiatives in architecture, daylighting, entertainment, light pollution, and dark skies. It has been his belief that lighting represents the best amalgamation of art, design, science, and technology. So Kenny has developed what he is about to present today as a method for developing and collecting data for the dark sky projects. But this method may also be applied to other types of projects. So Kenny, very interested to hear what you have to say to us. Thank you.
Good evening, everyone. I hope that's come through.
Yep, that's good.
So thank you very much, and good evening, everyone. My talk's going to be about, as I said, adapting to a digital future. So taking the unique project and approach on a different kind of job. So the job was to collect data spread out over a 28 square kilometre site, essentially the size of Belgium. In total, we collected just over 14,000 data inputs. The key benefits to the process that I'm going to show you are the reduction in errors, the saving of time, saving of money, the seamless transition between software packages and hardware packages, and generating or auto-generating reports and tender packages that can be sent out. So just to explain what the International Dark Sky Association is. So it was founded in 1988, and in 2001 they set up the award-winning Dark Sky Places program. This just encourages communities, parks, and areas to protect the night sky and educate people on what dark skies is. So as of January this year, there were 195 certificated dark sky places. Predominantly all of these had been done using a manual paper and spreadsheet based method. So this is just an example from the UK. So the Yorkshire Dales National Park, it's about a tenth of the size of the area that we were going to cover. It was already a national park itself, and in total 105 sky quality meters were measurements were recorded over a 2-year period. So that's a total of about 500 data inputs for their site. Moving on to the largest dark sky reserve in the world. So it is larger than the site we were going to cover. However, it's an amalgamation of other parks to create one overarching reserve. But in the report, the only area that has any SQM readings is that small green area, and that only had 23 readings in total. And as I said, these were all paper and spreadsheet based sets of information. So we were appointed by Red Sea Global. They're newly branded to that from the Red Sea Development Company, but they essentially wanted a hyper luxury tourism area, as I said, the size of Belgium. So the intention is to build 27 hotels, an airport, 10,000 worker homes, be completely off grid, while also then achieving international dark sky status. So when we got given this project, the thought was we're going to have to use lots of paper, lots of maps, manually input things onto the maps, write things down, then add it into a spreadsheet. And for the size and scale of the project, that would have been a lot of paper and a lot of information. So working that out, it was would be a total of around 43 days. So it would have been about 21 days on site just collecting the information. So what's that, 3 weeks, and then 4 days just managing that data. So taking that data, putting it onto a readable and legible CAD drawing or Excel spreadsheet. And then to find trends within that information would have been very difficult. So it would have taken around, say, 8 days to get that. And then the presenting of that information as well. So, I don't know, creating graphs by hand and just creating some information that the client is going to understand, and having a total of that amount of time, it felt like there was a different way to approach it. So I tried to come up with and use my youth, I guess, to come up with a digital method to go about doing that. So I was lucky enough, mainly due to COVID, to have to lead or get to lead a team of 4 people. We had 2 drivers. We occasionally had some few extra people on board for the journey, but we covered the whole site. So using, first of all, the digital method of Google Earth. So this is every route that we covered and every point that we stopped at. So both land and sea, they were both covered. These are just the statistics of what we actually managed. So over 11 days and nights, we collected 11,000 data points. So that was where we actually stopped and took the information, and that collated to around just over 14,000 data points. We covered 5,000 kilometers, so we could have driven to Morocco from where we were. We covered more miles on the sea. We could have traveled to Egypt and back. And then also it was 1,100 people hours. So for all of us, that's how much time we spent collecting this data. And as you can see, that's an image of us driving across the desert where there was nothing. It was also the logistical challenges of having to go to the islands. So we weren't allowed to go to the islands at night. We weren't allowed to stay on them. So we had to find a way to collect the data necessary overnight. So using these data loggers, we went in the day, planted them, and then set them to record, and then went to collect them the next day. Furthermore, there was the bigger logistical challenge of the fact that construction work on site had already started. Due to COVID, we weren't able to go before this. So for one night, they turned off all the lighting on the site. So security lighting, construction lighting, and any light that was on the site for 4 hours to get a true baseline of what was going on in the area. This is just to show the equipment that we needed. So a lux meter, a proper camera, so you have to be quite competent on being able to use a camera and use a fisheye lens to collect the information. a sky quality meter, a data logger. As I said, they were used on the islands, and kind of most importantly for collecting the data, either a phone or a tablet. So this phone or tablet can be used on or offline, it doesn't matter. Using an application called Survey 123, we were able to create a questionnaire. So I wrote this questionnaire and used it, changed it, and then we got down to this, and this is the one we actually used while we were on site. So it's just a tick box exercise to say what types of luminaires were in that area. And then most importantly, and the best thing was, it gave you a true GPS location of where you'd taken that information from. So you could take that exact point, add the photos, add the notes, get all the information, and it's all automated. This then gets sent through straight to a web-based online browser, so you're able to view the exact points in which data was taken. As you can see, I've clicked on one, and then it shows you all the information and the photos and the location of those fittings. This raw data can then be sent out into the dreaded Excel spreadsheet. So that spreadsheet, if I scroll all the way down, has all of that 14,000 cells in it. So versus that, there's 14,000 data inputs in that dashboard. So came up with a way to present all of that data in a way that can be manipulated and viewed. So I can now use the sliders at the top to find every area that sits at 21.2 SQM or above. This means that I can see every area that already achieves the required dark sky reserve level. Furthermore, I can do this the other way, so I can find every area that sits below 21.2 SQM, and then I can also find the main culprits and lighting within that area that's having the biggest impact. And you can keep clicking on different things and seeing those trends and seeing how it will work. This can actually get sent straight to the client as a dashboard, and they can click on it themselves and see these areas and see these trends. The software also allows for a template to be made to auto create reports and any appendix. So this writes my report for me. It gives me my whole appendix with all the lighting information. So if anyone ever said anything, they can flick through every page and see. This can also be given straight to the contractor. So you can write it in a way that it says every sodium light in each of these locations needs to be changed for this LED light source. This is just to show you one of the photos from the fisheye. So you can see where the light pollution is coming, and you can see that gorgeous gorgeous sky. So just to do a comparison of the traditional method versus the digital method. So the traditional method, as I said, is a total of about 45 days and would cost about £99,000 to do the job. That's for us to be on site doing it. So that's what it costs us. The digital method is a total of about 20 days. So can't get rid of the cost and the amount of time spent traveling to site, but the collection of data is significantly smaller. Managing the data is pretty much done by the software. So that's down to 1 day. And then, as I said, that understanding of what the data can do using Power BI and using those digital methods, and then actually being able to present it and have some information that the clients can easily understand. And it saves over £40,000 just to do this method. In addition, it's a reduction in errors. So over the 14,000 data inputs we had, there were actually only 6 incorrect visible errors, and I could see those errors using Power BI, and all it actually was one of us had put a decimal point in the wrong place, so it's easy to go and change that, and then the information sat and was correct. The method also just saves time, less money on site, less time spent collecting data, less time presenting that data, less time laying out the data, and less time writing reports, which I guess everyone would prefer. It saves money both for the company I'm working for and the client themselves. So we're able to put our fee in at a lower cost for them, and they're getting a greater and better outcome. There's a seamless transition between all of those software packages. So one enables the other to work with the next one, and it's the same with the hardware. They all speak together, and there's just a seamless transition between them all. So the benefits of adapting to this digital method are the fact that it speeds up the collection of data, it automates the report writing, it automates the analysis of that data, it creates repeatable and robust process. So I've now used this on 7 projects. So we have about 30,000 data inputs in total, and there's been very little to no errors at all. And we've got more projects where we're going to be using this as well. We gained new skills. So I used all the new different software types. And in addition to that, we were educating people on dark skies while doing the process itself. The transferable skills to other disciplines, so the software can be used for all different types within the company. There's a reduction in the time doing the work itself. It's actually very little education and training necessary in order to do it. So I was able to enable a team very quickly on site to go out and collect this data with myself. It's increased our impression to the International Dark Skies community and to the client and company themselves. It provides a new method for the IDA, so they'd never seen this method before. As I said, everything had been paper-based in the past, and it saves £40,000 just on one job, which is great. The future step.
Oh dear, I hope we haven't lost Kenny as well now. Kenny, I can see you're still talking, but we can't hear you. Kenny, can you try to switch on your mic and switch it off again, or the other way around? No, he's still talking. Okay, this is really, really unfortunate. We lost Hiba earlier. She lost internet connection from Pakistan, but I'm pleased to say that she is back now. Ah, Kenny, can you hear me now? Can you say something? No, he's gone. Okay, let's move over to Rahiba. Rahiba, are you there? Can you switch on your camera and your microphone?
Yeah, I'm sorry, there was some technical error. I'm really
That's okay,
sorry,
no
all the participants. Thank you for letting me in again, guys.
Don't worry, we knew we would be prone to technical hitches. So if you would like to carry on from where you left off, that would be really good.
Sure, sure.
Thank you.
Please let me know when you see my screen.
Sure, not yet. Yeah. Perfect. Thank you.
So while we were talking about how nocturnal animals get affected with light pollution, I was just talking about this. There's a small-scale hypothetical situation where a band of street or highly illuminated partition crossing these linear hedges can block these species from the other side. If you talk about bats, they are habitually very attractive to linear hedges, and they like to wander around at nights. But with this hindrance of heavy polluted road in between, they can just get confused, cannot get passed by, and
Are you still there?
yeah, am I audible?
Yes, I can hear you.
Can I move on?
Yes, please.
Okay. So coming to his amphibians and frogs like to migrate along the linear hedges, and they migrate to different locations to lay eggs. Having this polluted lane in between can restrict their movement, and they can also, just forget their ways. Many species like birds and nocturnal animals like to fly along the landscapes and wetland areas breeding and wandering. The migratory birds can also forget their ways and their direction, and they get disoriented with such heavy amount of light pollution. So certainly, certain species react differently to different lighting, and to further study this, a practical experiment was taken out where we have put certain animals, nocturnal animals and species in arena. Talking about turtle, larger-head turtle are strongly dependent on beaches to lay eggs and for breeding. So considering this diagram here, considering this arena, habitually they have to go back to the ocean in this direction after breeding process. What happens if we put white light in somewhere in this direction? See the linear lines here, they get attracted to white light spectrum and forget their ways to the ocean. Now, if there is amber light placed within this arena, and specifically in the direction of the ocean, you see how they are dispersed into 360 direction and forget their ways back to the ocean. If you see the diagram here where different spectrum is marked on the x-axis, and these dots are defining the responses of turtle. We see the blue spectrum is highly comfortable for them, and they are more attracted towards the yellow or red spectrum and get dispersed with it. Now, if we consider the situation for migratory birds here, putting them in a certain arena, and with wide light spectrum. If you see these pointers here, they are all dispersed in 360 direction. They're highly disoriented. Same goes with red light spectrum, where they are in flocks but still disoriented to high extent. But in case of green or bluish spectrum, we see that there is a less disorientation, and they're still in places, in flocks, and comfortable with blue or green spectrum of lighting. Talking about bats, there are very important nocturnal predators categorized into different breeds. The shy breeds of bats are mostly have discomfort with the different light spectrums. This experiment was carried out in birds where we placed different light spectrum into different areas, and actually calculate the responses. So if you see, they are very less active in white light and also in green light, but highly active in red light. If you see this bar graph here, they are very highly active in the dark, but in white and green light they are very less active. Same goes for the red light. They are very active, like they are active in the dark. Rats are also considered to be nocturnal animals, and they're very active at night. When we proceeded this experiment in them, it turns out that wood mice, they are very active in dark, and then they're only comfortable with red spectrum. And with wolves, there was certain certainly very different experience, because they're either very active in dark atmosphere or urban environment, but they're highly active in comfortable in red spectrum. For about foxes, mustelids, it found out that mustelids are comfortable in dark environment when there is no lighting, there is no light pollution. And they found to be comfortable in red and white spectrum more. And for foxes, they are actually very interesting again, where they showed very comfort in red spectrum, not that comfortable in dark even. So that's how animals actually react to lighting and spectrum and lighting urban environment. So with amphibians, it was certainly a very interesting exercise that was carried out, where certain groups of frogs were brought to these linear hedges, right, and across this road. What happened was that certain spectrum was given to the street lights, and the natural behavior amphibians or frogs is that they migrate to another location for laying eggs. What we wanted to see that how many frogs migrate to the other part of the road in order to um, lay eggs in certain light spectrums. Now here we see that in when there is no light spectrum, it's completely dark. Most of the frogs cross the road, but in white spectrum or in green or blue spectrum, they are not very comfortable. However, they were a bit comfortable in red spectrum. So conclusion based on animals' reaction. Limit light intensity and minimizing light remains the most important parameter. If we have to use warm light, 3000 K is best or lesser than that. If we can use red spectrum for our luminaires or fixtures, that would go for bats, rats, foxes, and certain kind of amphibians. For blue or green spectrum must be used for migratory birds, depending on the location and their abundance. Coming toward the application and lighting design part, I have designed light recipe considering 4 major ingredients. With this light recipe, we can confiscate light pollution and make environment inclusive for even humans and animals. Ingredient number 1, shielding. So if you can see the hypothetical designs carried out here, these are different levels of shielding. The best level is fully shielded, then comes partially shielded, and then is certain less than partially shielded. Considering the light phenomena here, it is suggested that best is the solution that is fully shielded and have downward direction to avoid any trespass and light pollution. Coming towards the partial shielding, in case if we have to use partial shielding due to site restrictions, what we can do is that we can add fixture with inclined head to restrict sky glow or trespassing and keep the light directed. If we are in case that we have to use somewhat shielded or barely shielding, then we can add diffuser to the light fixture material to avoid glare and trespassing. Certain hypothetical designs are also carried out for landscape outdoor lighting, where all the lights are aimed towards downwards, as landscapes are usually on land level. And in case a certain fixture cannot get the right aiming or direction, we can definitely add diffuser towards the light source to avoid glare. Ingredient number 2, light optics. It is found that the maximum degree that we can aim for outdoor lighting is 60 degree. We cannot go above that from the pole. And for the beams, it is suggested that we must use asymmetrical beams and symmetrical medium beams. If we go with this light optics, with this ingredient correctly, we're definitely going to confiscate light pollution in urban environment. Light spectrum, as we have discussed already, with certain kinds of shielding, if partial shielding kind of structure is there or a fixture is there, we can certainly use 3000 K or lesser with it, and that can perfectly go with most of the urban environments and animals as well. If we have to use a bluish or green spectrum for migratory birds, we can use barely shielding as well. And if you're using red CCT, we should make sure that the direction it is fully shielded because foxes, rats, and bats, most of the animals are on the land level. So that has to be made sure depending on the site situation. Very last ingredient in the recipe is control lighting. For that, I have created a scenario considering a road here where all street lights are actually connected to a system and controlled. And when a car passes by, they're all lit and then go dim. So in this way, we can control lighting and avoid trespassing and sky glow in whichever spectrum that depends on the location and abundance of animals. With these 4 ingredients and all of the research outcomes, I'm certain that we have come to our answer. And I'm sure that dark doesn't seem a bad word now. Sometimes dark means that it's functional lighting and it's right lighting application. So I hope that we are going to have darker nights. With that, I would just like to shout out to slogans, and I hope that the slogan is going to become the slogan of decades: turn off the lights to turn on the stars. Thank you so much.
Thank you very much, Hiba. That was very interesting. And I'm sorry you had to deal with the technical hitches, but I think we've all seen your presentation and understand it. So I don't think you will there'll be any detriment from that. We also had a bit of problems with Kenny's last few slides, and he is going to try and just go through those last few that we missed.
Hello.
So Kenny, are you there?
I am. The irony is not lost on me that I was doing digital things and it cut out.
And you haven't even got the excuse of being in Pakistan.
I don't, so I'm not sure what happened, but I can't do anything now. Can everyone see that? Was this about where I was up to?
I think it was, yes.
Okay, great. So I'll just go on to the benefits then of using this, the digital process rather than the analog process. So it speeds up the collection of data. It automates the report writing. It automates the analysis of the data. It creates a repeatable and robust process. So we've carried this out on 7 projects now with more than 30,000 data entries with very limited to no errors at all. And we're going to use it on future projects moving forward. We gain new skills, so new different software types, upskilling people on the ground, and educating people about dark skies in the process. The transferable skills across different disciplines within the business. We reduced the amount of time actually working on site and the work, desktop work, when we got back by around 50%. It requires little education in order to teach people how to use the software, as it's quite simple to just have a questionnaire. So it's very quickly and it was very easy and quick to mobilize a team while out in Saudi Arabia. It's increased our reputation with the International Dark Skies, the client and the company we're working for. We've provided a new technique for the IDA to use and help on future projects. As I said, we were the first to actually do it in a digital manner rather than doing it paper and Excel based. And essentially we saved £40,000 just in one job. The future steps will be to try and automate the collection in some way. So have drones go and collect the SQM readings over the mountains and over the desert, while also collecting photographs and doing this in the day and in the night to collect infrastructure photos and what's actually in those areas. So other projects that we've done this on, so I've done it on 3 projects in the UK, Pembrokeshire, Snowdonia and Cumbria, various projects in Saudi Arabia, and then a little bit closer to home, so using those principles of dark skies more than anything to a dark skies route, so having a small area of Salford and just having little to no impact from light pollution within that area. So yes, that is it. Thank you very much, and thank you for giving me the chance to present the rest.
Well, thank you, Kenny. It's a fascinating project, and I'm sure it was an amazing experience for you as well. Yeah. Right, I would just like to thank all 4 of our presenters. I think we've got some amazing presentations there. It's not going to be easy for the judges. They will now retire to decide who will be the overall winner. And whilst they do this, I am very pleased to welcome our guest speaker. Alwyn Manyonga will tell us about his experience after being named SLL Young Lighter 2020 and his journey in lighting since then. So I will see you back here later. Brendan, I can't hear any sound. I don't think the sound is coming through. Could you start the video from the beginning again, please, so that we can have the sound? No, there is still no sound.
You might need to click
Brendan,
on the bit.
Right, we can hear you now.
when you reshare your screen, Brendan, you'll have to let it have access to the computer audio.
It's in the top right.
Yeah, so you've got to stop sharing, reshare, and give it access to the computer audio, and then play the video, and then the sound should come through.
All okay?
No, there's still no sound.
Sorry, just talk me through that again.
So when you go to share, there should be share content, and then at the top it says include computer sound as a little toggle. In theory, you should be able to toggle that on, and it will play through what your computer is playing. You might have to tweak the sound a little bit, but that should be what the issue is.
I think I found it.
Cool.
Fingers crossed. Here we go.
Hello, everyone.
Wow, well done.
There we go.
Alwyn Manyonga, and I recently finished my electrical engineering undergraduate at the University of Zimbabwe. So currently I'm working as a junior lighting designer and electrical engineer at a local firm here in Zimbabwe. So I'm really glad to have this opportunity to share with you my journey on becoming the SLL Young Lighter of 2020, and I received these 2 lovely trophies, and I think this is one of the biggest awards I've won so far. So I just go through the presentation that landed me the SLL Young Lighter 2020 award. So my topic was titled Off-Grid Solar Lighting and Chukubulanteng, Africa's Education System Game Changer. So this topic seeks to solve poor access to high quality and reliable lighting, which is mainly due to poor access to electricity. 70% of the rural population in sub-Saharan Africa do not have access to electricity, and this has reduced productivity in the education, health, and other sectors where lighting is very crucial. So my work was trying to relate how lighting impacts our education system. Then on the topic, there are also issues like how lighting is actually contributing to climate change. Because globally, lighting consumes 19% of the world's energy, and it contributes to 5% of greenhouse gas emissions, which is a significant impact when it comes to climate change. Then there's also the rise in the amount of electronic waste from LED lighting, which is mainly attributed to the use of LED lights on AC systems. And LED lights require drivers, and these drivers have a lower lifespan when compared to the lifespan of the LED chip, which on average ranges up to 50,000 hours. So the solution that I proposed was off-grid DC LED lighting system. This is a completely DC LED lighting system that eliminates the use of inverters and LED drivers, because LEDs are naturally DC components, so we can actually drive them from power directly from a battery, and hence we remove the driver. And so when I pitched in 2020, this part of my project was more of a concept which I hadn't tried at that time. So after winning the award, I had an opportunity of trying it out. So I developed the completely DC LED lighting system, which uses less cables per lighting point, and the system is fully solar powered, and has potential of mitigating the effects of climate change. So at the core of this system, I developed a lighting control module, so as to maximize energy savings by giving users multiple ways of control. So on the lighting control module, there's also a smart lighting control module, which offers the user remote control via Wi-Fi, and it also gives the users real-time on and off status updates, and it also incorporates dimming, which is quite easier to do on a DC system when compared to doing it on AC LED lighting. Then by removing drivers, we improve the efficiency and the lifespan of the lighting as compared to doing it on AC. The second part of my solution was Chukubulanteng. So when I won the award, I had a prototype of this one, and I've managed to do more work on it and further developing it. So Chukubulanteng, firstly, Chigubu means plastic bottle in Shona, a Zimbabwean language. So Chukubulanteng is an LED lantern that is made reusing electronic waste and housed in plastic waste bottles. So the major electronic waste we used in making Chukubulanteng is from LED lighting. So as I highlighted in the first part of my problem, that LED lights usually fail very quickly on AC systems. So I realized that so when I looked into research, I realized that 60% of LED lighting failure is attributed to drivers, and usually when they fail, it's only the driver that will have failed, but we still have the chips very functional. So I check these lights and make new lights. So for the housing, I used a plastic plastic bottle of local beverages that are on the market. Then I also use reuse like lithium-ion batteries from consumer electronics as well. So I've done some designs of the charging and the driver circuit. There's a very simple circuit that I've built, which is easier to make and easier to maintain. So this project was mainly focusing on the student. So Chikubulantin has now become a social cause initiative. We also train students on how to make their own lantern. So for the schools, the lanterns come with a centralized solar power charger that is capable of charging multiple lanterns on a daily basis. So I have an 8-port charger that is capable of charging 24 lanterns on a daily basis. So students bring their lanterns to school for charging, then they take them back home when they're done charging them. So like I highlighted before, the SLL Young Lighter award comes with a huge prize money of £1,000, and you also get another £250 for just participating in the competition. So by getting this money, I was able to implement like the off-grid lighting part, which was more of a concept. So I did a successful trial implementation of the off-grid lighting system at a primary school that is here in Zimbabwe. So I did install a 300 watts system. That is, the system is provide lighting to a classroom at the school. So I think there is a picture there on top. You can see it's a classroom that's now being lighted using solar. And I collected some LED tubes that he had filled around my like from the University of Zimbabwe. So from there, I was able to make around 120 tube lanterns, which I've put on trials, like in various, like I've given them out for students to try them out. So the other thing I'm doing right now is skills transfer, where I train students on how they can make the lanterns and maintain them. So I'm hoping that this initiative will become more bigger and bigger, so that I manage to reach more students who come from like those rural parts where they do not have electricity. Then also like here, right now at the moment, we are also like being affected by unreliable power supply. Like we are having load shedding, which is lasting maybe up to 12 hours. So it turns out like this solution is also very crucial even to the urban areas where we have electricity, but it's not reliable. So then the impact of my work, I'm just rating it from the point that I pitched it from to the SLL, then I won the award, and up to now. So there is improved access to high quality and reliable lighting in schools, which is in turn improved performance for the students, because they now have enough time to study each night. Then for the school that I did install like the off-grid lighting system, they are now able to offer adult education and run like community events at the school during the night, because like they now have lighting, which is very crucial for those activities. And my two solutions are also helping in reducing the amount of greenhouse gas emissions, and also health implications of poor lighting, because like usually if people do not have high quality and reliable lighting, they end up using candles and kerosene lamps, which have negative health impacts. Then particularly the Chikub lantern is also helping in managing electronic and plastic waste through reusing. And since this initiative is also mostly focusing on students, so I try to also teach them like on how they can be more sustainable on what they consume and what they use. And this is the part of the knowledge transfer. So The other thing, by training the students, I've actually created a light that will last longer, because once it breaks, the students are knowledgeable on how they can fix it. So this has become a circular lighting product that is long lasting. And my work is in support of UN SDG 4, 7, and 13 by improving the quality of education by bringing high quality and reliable lighting, then also improving access to affordable and clean energy, because this solution is fully solar powered, and overall this is a more climate conscious way of providing lighting, which help us to mitigate on climate change. So I'll just show you a short video of the off-grid lighting system that I did implement on the school that I highlighted before. So let me just play. So the other features of this system are fully into all the wirings, using conduits and trunking, which is quite a good concept when we are looking at. But most of the solar lighting solutions that we have on the market we have a lot of training cables, which is expand the system. So I also highlighted that at the focus setting of the lighting performance, so you can see that I can control the lighting using Okay, so I think that's all on the video. So so the mantra of this whole initiative is to ensure a light for every student, because I realized that lighting was very important for me in my education. Okay, so as a personal testimony, the Chukublantian actually helped me when I was doing my third year, because I remember at the time we also had like the worst load shedding in our term, because like the main power plant that produces power in the country, which is a hydro power plant, like the dam had depleted water, so like the whole country was being affected by load shedding. And I remember that was in 2019. So after seeing about the SLL Young Lighter, that's when I thought I should present this idea to this community, and I actually won. So this quote by Nelson Mandela who said, "Education is the most powerful weapon that can be used to change the world." And I believe by bringing lighting to the education sector, we are equipping like these students so that they can change the world for a better place in the future. Okay, so yeah, thank you. That was the presentation there. So personally, as a recipient of the SLL Young Lighter Award, I think this has made a huge difference in my career, because looking at the Society of Light and Lighting, it's actually a very big community, and which is actually like on the internet, like everything is online right now. Because right now I'm in Africa, but I've benefited a lot from this organization, which is actually in the UK, and I've managed to access like many people who have been asking for help. So I think you can also try to follow me on LinkedIn, which is quite which is one of the platforms that the organization is using to reach out to its members. Then the other thing was like as part of the award, you also receive a free membership is an associate of the board as well. So this actually helped me a lot, because like there are a lot of guides that members can get on lighting design. So I've been reading through these, and yeah, there are a lot of opportunities that come with this award, even just participating in this award, was like the top 4 gets an opportunity of having like their videos on YouTube, which is quite good for everyone's CV. Yeah. Then there's also like the prize money, which is kind of a huge boost, because if I hadn't got this opportunity, my work would have been where it is right now. I got the money which I did, I invested back into the project. Then I was able to come up with more better prototypes, and my work has come from strength to strength. So I think if I do not mention this, yeah, I would have done a bad thing. So I remember like the night when the winners, yeah, the winner for the SLL Young Lighter was presented. So Ruth Kelly Wasket, like the president of the SLL of the Society of Light and Lighting, she did say something that is stuck with me from that day, which is like, yeah, it was those words of inspiration to me, and I really think they pushed me a lot. So she said, like, I would like to see your work going from strength to strength. Was it was really like a big thing for me. Was I'm here in Africa, then I did present something that quite impressed like a huge lighting community, a community of lighting designers. So this was a huge inspiration. So from that day, I haven't stopped working very hard. I haven't stopped working on that goal of ensuring a light for every student, because I believe if we teach these students on how they can they can use sustainable lighting, the best way of teaching them is actually by giving them like the sustainable products. Then we teach them about the circular lighting model and everything like that, so that when they grow up, like when they also get into the industry, they have an idea of what sustainability looks like to them. So I think, yeah. Okay, once again, I thank you very much, the Society of Light and Lighting, for giving me this opportunity for sharing my work. So I would like to say all the best to the winner of the SLL Young Lighter. Welcome to the big stage. I hope you enjoy your night. Thank you very much.
And Helen is back. Good news.
Hello.
Thank you for returning.
Well, that was a very, very stressful decision to make. It wasn't a lot of time to talk through everybody's opinions. But we have come to a decision. But first of all, I would really like to thank everybody that entered the SLL Young Lighter competition. And of course our finalists, who we feel did an excellent job, and I'm really sorry that 2 of them didn't have ideal conditions. I would also like to thank the judges. We've had several people involved in the whole process: Andrew Bissell, Matthew Cobham, Ellie Coombs, Maria Anglezou and Carolina Helene. And I'm sure you're all wanting to know who the winner is. So I can tell you that I have here the trophy, and I am very pleased to announce that Scott Kluger is our choice of winner. It was a very hard decision. We were very torn, but we feel that Scott's research could be extremely useful. It's something that could really make a difference to the industry if this can be rolled out and everybody understands it. We feel there's a little bit more work to do, but really a very, very good start, and therefore we feel he's a very worthy winner. So congratulations, Scott. We will get the trophy off to you as soon as possible, and it will be coming through the post to you. So
thanks,
well
Helen.
done.
Yeah, just from myself, just want to say thanks to the SLL for giving myself as well as Anna, Hiba, and Kenny the platform to show our interest in lighting, and yeah, just big thanks to you and Brendan as well for organising the event this evening too. So thanks.
Oh, thank you. Well, exceptionally good paper, and well done. Thank you. So all that remains to me is to say thank you to all of you for logging on, for listening and watching, and I hope you have enjoyed it as much as I have done, and enjoy the rest of the evening. Thank you very much for listening. Bye bye.